Hello everyone and welcome. My name is Yogesh and I'm truly honored to be here today to discuss a topic that's becoming increasingly crucial in our digital world. Best practices for securing machine learning pipelines. Before we dive in, I want to express my sincere gratitude to Mr. Subramaniam sir from ISSS for giving me this wonderful opportunity and share my insights on this pertinent issue. Today, we'll explore how to safeguard the very heart of modern AI systems, the machine learning pipelines that power them. We'll look at the unique security challenges that face, more importantly, how to address them effectively. Let's begin by understanding why this topic is so important. Machine learning pipelines are the engines driven AI powered applications. However, they introduce complex securities. The intricate natures of machine learning models, their reliance on massive datasets and dynamic environments, which create attack surfaces that traditional cybersecurity might often miss. Think about a facial recognition system. If its training data is compromised, it can lead to misidentification, a vulnerability traditional network security might not catch. Today, we'll explore best practices to secure these pipelines, ensuring integrity, model reliability and compliance. Now, what exactly is machine learning pipeline? It is structured workflow with key stages. Imagine it as a set of steps. First, data collection, where we gather information from different information from databases, APIs, or sensors. Data pre-processing, where we clean and prepare the data. Feature engineering, where we extract relevant features. Following that, model training, where we develop predictive models, model validation and testing, ensuring accuracy and robustness. And finally, deployment and monitoring, where we run the models in the production. Each of these stages has unique security challenges requiring tailored protective measures. Let's talk about the security risks among them. For example, data poisoning attack, wherein the attackers inject malicious data in the bias models. Model inversion attacks, wherein the attackers extract sensitive training data. Adversarial attacks, where the attackers deceive models with the crafted inputs. Supply chain vulnerabilities, these are the risks from the compromised third-party libraries. Unauthorized unauthorized access and data leakage, which might cause due to exposing the sensitive data. And finally, model theft and reverse engineering, this might cause due to the stealing of the intellectual property. Now let's discuss about the best practices and the solution to these threats. So, for data security and integrity, we need to implement rigorous data validations to check validation checks to filter out the malicious inputs to ensure the data quality. For model security, we need to use adversarial trainings to train models and resist attacks. Ensure secure model sharing by encrypting and controlling the access. For infrastructural deployment security, we need to secure the CI/CD pipelines with code signing and vulnerability scannings. We need to use isolation mechanisms for creating sandboxed environments. For monitoring and logging, we need to use anomaly detection with AI-driven monitoring, maintain audit logs, and track data access model training. And last, for the access control and authentication, we need to implement RBAC, role-based access control, to limit the access. We need to use MFA, multi-factor authentication, to strengthen the authentication and ensure API security by protecting the APIs with the authentication. Compliance is crucial. We need to consider frameworks like GDPR for data privacy, ISO IEC 27001 for information security management, NIST and AI risk management framework for securing the AI systems, and HIPAA for the healthcare data protection. Emerging trends include zero trust architecture for strict verification, blockchain for data integrity to prevent tampering, explainable AI to detect the biases, and AI powered cybersecurity for real-time threat detection. So, to conclude, securing machine learning pipelines requires a proactive approach. By implementing these best practices, we can ensure the integrity and reliability of the AI applications. Thank you for your time. I hope the presentation uh, provided This presentation has provided a valuable insights into the securing the machine learning pipelines.